Welcome to Brain Vision.
The magnetic force, which is given by I times L times B sine phi, must be equal to the gravitational force given by m times the acceleration due to gravity when the bar is just ready to levitate. This gives ILB sine phi equal to mass times gravity. Here phi is 90 degree because the magnetic field and length are perpendicular to each other, so sine phi becomes 1. This means that I will be given by mg over L times the magnetic field. We solve this using the values up here and we get this current to be 32.67 ampere. Now we can find the voltage, which will just be equal to I times the resistance, and resistance is given to be 25 ohms. So we use these two values over here and we get the voltage times 25 ohms, and we get the voltage to be 817 volts. So this is the first part. For the second part, the resistance is 2 ohms now because of the short circuit. So in that case, we will have, just let me check for a bit. Yeah, so because of the partial short circuit, the resistance is decreased to 2 ohms now. So here the current will then be equal to the voltage, which is this value that we calculated, over the new resistance, that is 2 ohms now, and we get the new current to be 408 amperes. From here we can find the magnetic force now. So this will then be equal to, let's just call it force. This will then be equal to the same as this. Again here sine phi is 1 because phi is 90 degree, and we calculate the force to be equal to 92 newtons. And now we use Newton's law. So Newton's law says that summation of all force is equal to mass times acceleration. Here we have two forces, the magnetic force, which is ILB, and there is a gravitational force which is in the opposite direction, so a negative sign over here, and this is equal to mass times acceleration. This gives acceleration to be equal to F, which is ILB time minus mg over the mass, and we calculate this acceleration to be equal to 113 meter per second square.